Hi, welcome to Elonix. In this episode, we'll see how to make a clap switch or sound triggered LED while simultaneously learning how it works. This circuit detected claps up to a distance of about 15 feet. And if you are near, the LED turns on even with finger snaps. You can also change the sensitivity so that it turns on the LED only when you clap near the circuit. We'll be using a condenser or electret microphone as the sensing element, and its capacitance changes in response to ambient sound. So we'll start with the condenser microphone and a resistor in series so that the change in capacitance of the microphone is translated to change in voltage at this point. One terminal of the 3.3 kilo ohm resistor is connected to negative rail and the other terminal is connected to negative of condenser microphone, which is the pin connected to outer casing, and the positive terminal of the microphone is connected to the positive rail. The voltage at this point is normally near positive voltage, but it drops whenever there is a sudden loud sound around the microphone. We'll try to amplify this response by using BC547, an NPN transistor. So connect this point to the base of BC547, which is at pin 2, and the emitter, which is at pin 3, should be connected to negative rail. Connect a resistor between positive rail and the collector of transistor. This resistor acts as a dummy load which keeps the collector base junction in reverse bias, and that's required for making the transistor amplify the input signal. And because this resistance determines the voltage at the output, its value determines the sensitivity and is dependent on the supply voltage. So if you are using a 5 or 6 volts of power supply, use a 270 ohm resistor, 470 ohm for 9 volts and 1 kilo ohm for 12 volts of power supply. Increasing this resistance value reduces the sensitivity. Now this is not required, but if you place an LED between the output and negative rail, the LED glows when you tap or blow air on the microphone. But the output is not high enough to detect claps. So we will use another NPN transistor and connect the output of the first transistor to the base of the second transistor BC547. Like you did for the first transistor, connect the emitter of the second transistor to negative rail and the collector to load. At this moment, we'll be using an LED as a load to test the circuit. So I have connected the collector of second transistor to negative terminal of the LED, and the positive of LED connects to positive rail via a 270 ohm resistor. This resistor should be 470 ohms for 9 or 12 volts of power supply. Now turn on the power supply. Normally the LED should stay off and it should turn on when you clap or do finger snaps near the condenser microphone, or even if you tap or blow air on it. Don't panic if the LED always stays on. All you need to do is increase the load resistance of the first transistor. For example, if you are using 270 ohm resistor, replace it with a higher one, say 330 ohm resistor, and keep increasing until the LED just turns off. I advise you to purchase at least 3 resistors and start from the minimum. If the LED stays on, you'll use the next resistor and so on. Coming back to the main circuit, even though it turns on LED with a clap, it stays on only for a moment, and normally we would want to increase that duration. And obviously a 555 timer in monostable mode is the best candidate for doing that. What this arrangement does is, whenever the trigger pin detects a drop in voltage, the 555 timer turns on the output for a duration determined by the value of capacitor and resistor. We will first build this monostable circuit and then couple the trigger pin with the output of a primary circuit. So let's place the 555 timer IC on the breadboard, connect the pins 6 and 7 and pins 4 and 8. Now connect a 100 kilo ohm resistor between the pins 7 and 8. Next goes the capacitor with its positive terminal connected to pin 6 and its negative terminal connected to negative rail. You can choose the capacitor's value depending on the amount of time you require the LED to stay on. Now connect the output of 555 timer, which is at pin 3, to the positive of the LED and the negative of the LED to negative rail via a 270 ohm resistor. Connect pin 1 to negative rail and pin 4 to positive rail. You can now test this monostable circuit by applying 0 volts at the trigger pin. Now it's time to couple output of a primary circuit with the trigger pin of this monostable circuit. As we don't require LED at the output of a primary circuit, I am removing it along with its series resistor. Place a 1 kilo ohm resistor between the collector of second transistor and positive rail. This resistor acts as a load for the second transistor as well as keeps the output high when the transistor is not turned on. After this, use a 100 nanofarad capacitor to couple the output of the second transistor to the trigger pin of 555 timer IC. The capacitor acts as a filter and prevents continuous loud sounds from triggering the monostable circuit. So normally the voltage at the trigger pin will be near to positive voltage and it drops whenever you clap, which triggers the monostable circuit, and so the LED should glow. Finally, connect the power supply and here you go, the clap switch or sound triggered LED. Thanks for your time, do subscribe and have fun.